Alright, so we're going to look at the second half of 2.3 notes, so 2.3 part 2. We're going to start with the rational zero test. So the rational zero test gives us all the possibilities of zeros that we could have, and we can test those possibilities to see what's actually one of the zeros of our function. So we're going to use this P over Q, where P are all the factors of our constant, and Q is all the factors of our leading coefficient. And then how we're going to test to see if that is a zero or not is by doing synthetic division. So we use the rational zero test to first list all the rational numbers whose numerators are factors of the constant term. So factors of the constant go on top, that's our p's, and then the denominator are factors of the leading coefficient, so that's our q. So it's p over q. And that gives us all of the possible rational zeros. So these are possibilities, and we just have to test them to see what's an actual zero or not. So in example 7, we have to find the rational zeros of our function. Here we can't factor it, it's x cubed, and it doesn't give us something to divide into it right off the bat. So it doesn't give us something to test whether it's a factor or not. So it only gives us the function. So we're going to take all the factors of our last term, which all the factors of 1 are just positive or negative 1, over all the factors of our leading coefficient, which here, again, it's just 1, so positive or negative 1. It'll always be positive or negative on the top and positive or negative on the bottom, because we can multiply -1 and -1 and get positive 1. So these are all of our possibilities. If we listed them all out, that would be positive 1 or negative 1. So let's test it. We're going to do synthetic division to see which ones are 0 or not. They might both end up being our 0, but we'll test it and then break our function down to something smaller where we might be able to factor it. So I'm going to start with 1. When doing this, we'll have more factors of the constant term, so we'll get more possibilities, but it's always best to start with 1 because it's the least amount of work you have to do and just easier to multiply by 1. So I'm going to start with 1 on the outside. On the inside, I need all of my coefficients of my function. So I have x cubed to start. I don't have an x squared, so in here I'm going to make sure that I include a 0x squared. So I have to put that 0 in the x squared position. So I have 1, 0, 1, and 1. And then I can go ahead and do synthetic division. So drop down the 1. 1 times 1 is 1. Add, we get 1, multiply, add, multiply, add. So I don't get 0 as my remainder, so I know that this is not a 0 of my function. So next, let's try -1. So I have -1 on the outside, same coefficients, 1, 0, 1, 1. Drop down the 0, drop down the 1, you get 1, -1, -1, 1, 2, -2, negative. So -1 actually doesn't work either, and because both of our possibilities for rational zeros don't work, here we have no rational zeros. So because we tried all of our possibilities here and neither one work, we have no rational zeros. Alright, so on example 8, I'm actually going to change this. So I'm just going to get rid of this whole function and make a new one. So I want this to be x to the third power plus 8x squared plus 11x minus 20. So we want to list all of our possible factors of 20 or -20, but it's always going to be plus or minus. Factors of 20 would be 1 and 20, 2 and 10, 4 and 5, and that's it. And then we list all of our factors of 1, which is just positive or negative 1. So it's always best to start out by testing 1. So we're going to start by testing positive 1. But just remember, we also have the negatives of our possibilities here too. So we can also try the negatives. But I'm going to start with positive 1. I'm going to put all my coefficients inside my box. So I have 1, 8, 11, negative 20. I'm not missing anything. I have cubed, squared, 1, and 0. So drop down the 1, multiply, add, multiply, add, multiply, add, we get 0. So that means that 1 is one of our factors. So x is equal to 1 is one of our rational zeros. Now I have this smaller factor of my starting function to work with. So since I started with x cubed, my answer is now going to be x squared plus 9x plus 20. So I can either do this again, find my p over q again, so list all my factors of 20 over my factors of 1, or I can ask myself, what are 2 factors of 20 that add to 9? So that would be 5 and 4. So this would break down into x plus 5 times x plus 4 equals 0, because I'm finding my zeros here. So x is equal to negative 5. I just set each piece equal to 0. X plus 5 equals 0. Subtract 5. X equal to negative 5. Do the same thing for 4. Subtract 4 on both sides. X is equal to negative 4. So if x is equal to 1, x is equal to negative 5, and x is equal to negative 4. So if I would have started out by testing negative 4 or negative 5, they would have worked in my synthetic division as well. So you could test any number you want. It's always just easiest to test 1 first. So these are my 3 factors of my function, my 3 zeros, which makes sense that I got 3 answers because I started with x to the 3rd power. So that leading degree tells you how many zeros you're going to have. I'm going to add another example in here for you guys also, just so we can practice a little bit more since there was only 2. And one of them didn't even have any real zeros. So x cubed plus 2x squared minus 5x minus 6. So I'm going to start by listing all my factors of my constant, which that'll be 1 and 6, 2 and 3, and that's it. And this is a plus or minus. And then all my factors of my leading coefficient, which is just a positive or negative 1. I'm going to start by testing 1 first, just because I think it's the easiest. But you could start by picking any number from here that you want. I need to put all my coefficients inside my box. So I have 1, 2, negative 5, negative 6. Make sure I'm not missing any. I have cubed, squared, 1, 0. So I got all my degrees in order. I'm going to drop down my 1, multiply, add, multiply, add, multiply, and 1 doesn't work. So let's try something else. I'm going to try 2. So I have 1, 2, negative 5, negative 6. Bring down the 1, multiply, add, multiply, add, multiply. It works. I didn't even know it was going to work. Let's go. Alright, so 2 works. One of my zeros is x is equal to 2. Now I have a smaller function that I can work with. This is a factor of my original here, so I just need to break down what I just got. Since I started with x cubed, this is x squared plus 4x plus 3. I could do p over q again with 3 and 1, or I could just ask myself, what are my factors of 3 that add to 4? So that would be 3 and 1. So I have x plus 3, x plus 1. I'm finding my zeros, so I set it equal to 0. x plus 3 equals 0, x plus 1 equals 0. Subtract 3 on both sides, x is equal to negative 3, and x is equal to negative 1. So add these to my list up here, I get x is equal to negative 3, and x is equal to negative 1. So these are my 3 zeros of this function here. And I know that I am going to get 3 answers because I start with x to the 3rd power. I'm going to do one more example just for fun. So if you feel comfortable with this and you want to keep working on the homework, make sure you turn in your notes and you can start working on that. But if you want another example for practice, here's another one. So I have x to the 4th power minus 4 x cubed minus 13 x squared plus 4x plus 12. So I'm listing the rational zeros. I need to start by listing my factors of my constant. So that would be 1 and 12, 3 and 4, and 2 and 6. And that should be all of them. This is plus or minus. And then that's over all my factors of my leading coefficient, which is just 1. So I'm going to start by testing 1, and I need to put all of my coefficients in my box. So I have 1, negative 4, negative 13, 4, and 12. Drop down the 1, multiply, add, multiply, add, multiply. This would be negative 16, add, negative 12, multiply, negative 12, and it works. How exciting. I love when it works. Alright, so 1 is one of our factors. So I'm going to make a list over here. X is equal to 1. That's one of our answers. We know we have to find 4 answers. So let's do it again. My constant here is 12. So I'm going to have the same P over Q that I started with here. So I can put my coefficients in a new box. 1, negative 3, negative 16, negative 12. I always take my answer and use those coefficients because it's a factor of the original. So it's just smaller to work with, and our goal is to break it down into all the zeros. So after we find another one, then we have a quadratic, so we could just factor it normally from there. I am going to try 2 now. I don't know if it'll work, but let's see. So drop down the 1, add, multiply, add, multiply, negative 2, add, this would be negative 18, multiply, it doesn't work. Too much. I can see it's not going to cancel out, so I'm going to pick something else. I'm going to try negative 1 and see. Drop down the 1, multiply, add, multiply, add, multiply, add. Awesome, it works. So negative 1 is also one of my zeros. Negative 1. And now, since this was an x cubed, this is going to be an x squared minus 4x minus 12. So I can factor it normally from here. What are 2 factors of negative 12 that add to negative 4? That would be 2 and 6 has to be negative. So x plus 2 times x minus 6 equals 0. X is going to be equal to negative 2, and x is equal to positive 6. So I can add those to my list as well. X is equal to negative 2, x is equal to positive 6. These are my 4 rational zeros that I just found. So you guys can work on the WebAssign. Email me if you have any questions. A couple things to know about the WebAssign, because I got a couple emails already, so I said this in one of my classes, but I don't think I knew how WebAssign wanted to leave your answer when I taught it in C period. So for number 2 on WebAssign, it wants you to leave your answer in factored form. So it asks you to divide I don't know what the polynomial is, but let's just say x cubed plus 3x squared plus x plus 6, something like that, and it wants you to divide it by x plus 2. So you take your x plus 2, that's going to be part of your answer, and whatever you get when you divide it. So let's just say we get x plus 6 also when we divide it. There would be more factors, but just an example. You get whatever your answer is, and you have to write it by whatever you divided it into, So this is how you would leave your answer in WebAssign. Also, you would leave your answer like this if it asked for the linear factorization. It wants you to leave your answer in factored form, like how you list all your factors in the parentheses. So break it down, find all your factors, you would leave it like this. So number 2 on WebAssign wants you to leave your answer like this. Also, I believe that it is 11 and number 12. I think it's C for both of them, where it asks for linear factorization, so you have to leave your answer like this. So again, if you have any questions on WebAssign, send me an email. I'll try to answer them right away. Have a great day. See you on Tuesday.